All right, folks, it's Fast Action, back in action here. In this video, I'm going to go through two new skills related to our imaginary numbers and some skills that you need to be comfortable with when working with imaginary numbers. The first one is going to be finding remaining zeros when you are given an imaginary number as one of the zeros. Now, I do want to point out with this particular problem, it would be good for you to recognize that on this problem, if I gave you this problem on an assessment or on a practice set, that this problem actually factors by grouping. Now, typically when we give you something with an imaginary numbers, this is not going to factor through any other method, and you're going to have to work with the imaginary numbers. But it would be good for you to take a moment and just recognize that this one does actually factor by grouping. Now, let's jump into what you would do if it did not factor by grouping. And we've got two different choices here, and it truly does not matter which of these two methods you choose. Some people are going to naturally gravitate towards the long division. They're going to feel more comfortable there. Other people are going to feel more comfortable with the synthetic. It doesn't matter which one you do. You're just going to pick the one that you feel most comfortable and that you can get from start to finish without making a mistake. Okay. If we give you a zero that's imaginary that we're starting you off with, you first need to recognize that our imaginary zeros always come in pairs. So if 3i is a zero, then so is a negative 3i, okay? Now, if we're going to do long division, what you're going to do is you're going to take each of those imaginary numbers and we're going to write them in their essentially a factored form, okay? So we're going to say x minus 3i, and we're going to say x plus 3i, and then we're going to quick FOIL that out, recognizing that this is going to become x squared, and of course this is a difference of squares, so the middle and these middle product and this outer product are going to cancel. So we'll get an x squared minus a 9i squared, which of course then is going to simplify because I squared is a -1 to x squared plus 9, okay? So you're gonna have to do that every time. Now, the next thing that you're gonna do is you're gonna set up your long division. You're going to take that x squared plus 9, and we're going to go ahead, we're going to put that out here, x squared plus 9. Then we're going to set up this long division, and we're going to take the entire polynomial that we want to divide this into, and that's going to be our 2x cubed plus our 4x squared plus our 18x plus our 36. And we're just going to start that long division same way we always would. We're going to take our x squared and our 2x cubed, and we're going to divide that out. Again, you can always write that out kind of over to the side, 2x cubed divided by x squared, and we know that that's going to give us a 2x. Then we're going to multiply that. 2x times our x squared is, of course, going to give us a 2x cubed. That's the whole point. 2x plus times the 9 is going to give us an 18x. And then we're going to do our subtraction. So I like to change the sign and add. So those cancel. Then in fact, these also cancel, which is kind of convenient on this one. So I got to remember to pull down this 4x squared and pull down the 36. And I'm going to continue my division again. So 4x squared divided by x squared is going to give me a plus 4. Multiply that out again, and I'm going to get 4x squared, and again, a plus a 36. And of course, when I change these signs and I add, I get a 0. Now, I have to get a 0 here, all right? Remember, these are both supposed to be zeros, so their product should give me a remainder of 0. If it doesn't, then I know that I did something wrong. So now when I'm looking at all of my zeros, if I'm going to list those out, what I'm looking at is this expression up here at the top, and I'm essentially setting this equal to 0. Now, I don't typically need to write this out, but we can. We would say 2x plus 4 equals 0, and of course, when we solve that little equation, we get x equals a -2. So if it asked you to list all of your zeros, okay, if it asked you to list them all, you would say our plus and minus 3i, and then we would, of course, then say our -2. Now remember, typically these would not factor by grouping from the beginning, so this would be your choice. Now, our next method is going to be synthetic division, and some of you are going to like this and some of you are not going to like this, okay? So let's take a look at the synthetic division. It also is dependent on remembering that you have both of these zeros, okay? You have a 3i and a negative 3i. You must do your synthetic division twice, okay? So when we do our synthetic division, we're going to start with whichever zero we want. I'm going to start with that 3i, okay? So I'm going to give myself my 3i. I like to make my box this way. You might do yours a different way. I'm going to go ahead, I'm going to write my coefficients here, my 2, my 4, my 18, and my 36, because all of my degrees are represented. And I can start my division. So remember, we're always going to start with the 0 here, and I'm going to have a 2. So I'm going to have a 3i times a 2, and that's going to give me a 6i here. Now, when I add this, I am, in fact, going to get 4 plus 6i. Now, when I multiply the next time around, it's going to be 3i times 4, and that's going to give me 12i. And then it's going to be 3i times 6i, and that's going to be a plus an 18i squared. Now, of course, 18i squared is really the same as a negative 18, because I squared is a negative 1. So when I add these together, these 18s are going to cancel, and I'm left with the 12i here. Oops, didn't mean to do that, sorry. 12i. And then when I multiply again, 3i times 12i, I'm going to get 36i squared, and of course I squared is negative 1, so this is the same as a negative 36, and I get a remainder of 0. Just like back here, you have to get a 0 here. If you don't get a 0, then you made a mistake somewhere here with your imaginary numbers. Now, we need to keep going until all of the i's are gone, okay? So we've got to repeat this process with the negative 3i. We're going to continue this process, and I'm going to have my 0, and I'm going to have my 2, and this time I'm going to have a negative 6i, and that's going to be pretty easy because those are going to cancel, and I'm going to get a 4, and then I'm going to multiply again, negative 3i times 4, and that's going to give me a negative 12i, and of course those are going to cancel, and I get my 0 just like I wanted, and sure enough, when I look right here, I've got the same thing as I had right there. I've got 2x plus 4. I can set that equal to 0 and get that 0 of x equals a negative 2. So again, my same zeros are going to happen. I have my plus and minus 3i, and I have the negative 2. Okay, again, choose whichever method you feel the most comfortable, so take some time to reflect on this and decide which one that you like better. Now, the next one that we're going to look at is writing a polynomial function when we're given a more complex version of our imaginary solutions. So typically we've only been working when we just had maybe an I, but now I'm going to give you one that has both the real and the imaginary portion instead of just the imaginary. So we've got two different parts to this, okay, that we want to look at. The first part, I'm going to take the easy part first, and that's going to be this 0 of a 3 that says that it has a multiplicity of 2. That means that that 0 of 3 has been repeated twice. So we're going to first just take this real quick, and we're going to write x minus 3 and x minus 3. And of course, we know that that would FOIL out immediately to give us an x squared minus 6x plus a 9. Now we're just going to save that little piece for a moment until we get done with this part right here. Now, if 2 plus I is a 0, then we also are going to have 2 minus I, okay? We're going to have those complex conjugates. So the first thing that we're going to do, just like up above, is we're going to write these in their factored forms. So I'm going to say x minus this 2 plus I, and then I'm going to say x minus the 2 minus I. So, and notice these parentheses. These are some pretty important parentheses here. In fact, I'm going to go back and I'm going to even write those in a different color, okay? So we've got to make sure that we recognize those parentheses. Now there's a variety of ways to multiply this out. I'm going to do a different method here. I have another video. If you don't like this method, or in class I can show you another method of how to multiply these out. We're going to go ahead and we're going to distribute these negatives. Okay, so we're going to have x minus 2 minus I, and we're going to have x minus 2 plus I. Okay, now we're going to FOIL all of these out. Okay, so I'm going to start with this x and I'm going to distribute to all three parts. So I'm going to have x squared, and then I'm going to have minus 2x, and I'm going to have minus xi. Okay, oops, I meant to say plus xi there, plus xi. So I took my x here, and I took my x there. Now I'm going to take this negative 2 and I'm going to distribute it, and I'm going to get a minus 2x again. And my negative 2 times my negative 2 is going to give me a plus 4. And I'm going to tuck that out here because it doesn't line up with any of the terms that I've already had. And now I'm going to take that negative 2 here, and I'm going to have a negative 2i. And I'm going to go ahead and I'm going to line that up with the other i's. Okay, so minus 2i. Now I'm lining up all the i's even though these aren't like terms, because all of these i's are supposed to cancel out. The next thing that I'm going to do is I'm going to distribute the I. So I'm going to distribute here, so negative ix, and I'm going to, which can also be negative xi if I want to match those up. Then a negative I to here, so that's going to be a negative, positive 2i. And I'm going to do my negative I to here, and that's going to be a negative I squared. Now, I'm actually going to put this one out here with the 4, because what I know is that I squared is a negative 1. So when I look at this, I see these cancel, I see these cancel, and negative I squared is a negative 1, so this is effectively the same as a plus 1. So that means that all of this together, I'm going to have an x squared, I'm going to have a negative 4x, and I'm going to have these terms here, this 4 and this 1. So this whole thing together is going to become x squared minus 4x plus 5. Okay, so all of this is going to become that. Now, I'm going to take that, and I need to multiply it by this x squared minus 6x plus 9. And now I'm going to FOIL all over again. So again, now I'm going to take my x squared and I'm going to distribute that. I'm just going to continue this process. So now I'm going to have x to the 4th minus 6x cubed plus 9x squared. I'm going to keep going. Now I'm going to distribute the negative 4. So I'm going to have a negative 4x cubed. And then I'm going to have a plus 24x squared. And then I'm going to have a minus 36x. Then I'm going to distribute the 5, and I'm going to have a 5x squared. Notice each time I'm lining up the terms that are similar. Then I'm going to have a minus a 30x. Oops, 30, not 36, minus 30x plus 45, okay? Now, if I give myself kind of a line here, and I can just now add everything straight down. This needs to be an equation, so we're going to make sure to write a y equals now, and I'm going to have x to the 4th minus 10x cubed. Add all of these together. I'm going to end up with plus 38 x squared minus 66x plus 45. And that is going to be our final answer. Notice that even though we started off with imaginary numbers, we should not have any i's in our answer when we are all done.